Now let's see this. They are saying that two matrices M1 and M2 are to be stored in arrays A and B respectively. So that means that there are two matrices M1 and M2, and they are in the arrays. That's it. Okay. And now when a matrix is represented in array, then definitely that is a two-dimensional array, isn't it? That is how we represent it. And each array can be stored in either row major order or column major order in contiguous memory locations, which means they are saying either A and B can be used in row major order or column major order representation. The time complexity of an algorithm to compute M1 into M2 will be, so they are now talking about the time complexity. Now how can you find out the what is the representation or what is the storage mechanism, the scheme that you use, which is going to give you a better time complexity of the algorithm, right? So actually algorithms, whenever we discuss about them, we never talk about the time complexity related to storage scheme, which means algorithm is independent of the storage scheme. Algorithm assumes that all the elements whichever you refer are going to be available to you at a uniform rate, which means if I refer to an element of A or to B, whatever the storage mechanism is, algorithm basically assumes that the time taken to access any element is same, but then the implementation time will vary depending on the storage. Therefore the algorithm will never be dependent on the storage scheme, right? So independent of the storage scheme, the algorithm time complexity, right? Now what if I just change it, the time complexity of an implementation to compute it, instead of algorithm, if I change the word to implementation, right? So if I try to implement it, then let's talk about it. So when you try to implement this, how are you going to implement it? You will be writing a program in such a way that, right, generally the general programs will be like this, right? So you are going to write the program in such a way that you will access row of this A and then column of this B, and you multiply the corresponding elements and you access them, right? Therefore storing the A in row major order and storing the B in column major order is beneficial. The reason is, whenever you try to get the first element of A, entire row of A will be fetched in case if you have row major order, because the chances are that one row might fall in one page. Therefore whenever you have the first element, the successive element accesses will be easier, right? Because they will be present in the main memory or in the cache. And similarly, whenever you get the first element of B, the successive elements will be present in the cache, isn't it? So it is better that so whenever you are going for this implementation, you see that A is represented in row major order and B is represented in column major order. If you go like that, it will be easy for you to implement it. I mean, the number of page faults or the cache hits, cache miss will be less, right? So in case of implementation, the better one is best if A is in row major order and B is in column major order. For algorithm, it is independent of storage concept. Algorithm always assumes that the storage is in such a way that any element can be accessed in uniform time. But then when it comes to implementation, accessing every element will take different time, because sometimes there will be page faults. So if you want the best performance possible for the implementation for such a program which is going to multiply this way, then that is the normal program, right? We have the multiplication. So A you store it in row major and B you store it in column major, and then accessing it will be easy. Okay, fine.